a Pythagorean identity to mess around with. You don't have any scenario to go anywhere with. When you have fractions and both your numerator and the denominator have pluses or minuses, create a complex fraction. Create it in terms of a stacked fraction and try to get common denominators. For example, numerator becomes 1 over 1 plus 1 over cosine over sine over cosine plus sine over 1. What I'm doing here is I'm going to create the stacked out complex fraction to show that it's going to work here in a second. So all I do is just simplify each numerator and then the denominator independently of one another, and then I'll put them all back together. So common denominator at the top is going to be what? Cosine. So the common denominator up top here is going to be cosine.
I thought it was 1 plus cosine.
Well, when you multiply, you get your common denominators, you multiply. So fraction on the left needs a cosine. Fraction on the right doesn't need anything, so it's going to be cosine plus 1. Okay? I do the same basic idea on the bottom. Again, I wind up the common denominator between cosine and 1 as cosine. The numerator, fraction on the left has a sine, or excuse me, has the cosine. The one on the right doesn't. So it winds up being sine plus sine times cosine. Everybody okay with that? Now, this is the next step that most people that I've come across today tend to have an issue with. So what would you do if you had this and you needed to simplify? Take out a 4. If you factor out a 4, you get 4 times x minus 1. Well, what do those guys have in common? A sine. Factor it out. And then this guy just comes right over here. So right now I have cosine plus 1 over cosine, all divided by sine times the quantity 1 plus cosine over cosine. Remember, when you have a stacked fraction, a complex fraction like this, you take the top fraction, it's divided by the bottom fraction. So I'm going to flip the bottom fraction when I come up to multiply by its reciprocal. So I wind up now with cosine plus 1 over cosine times cosine over sine times 1 plus cosine. What happens? Things start dropping here. Cosine plus 1 goes away, cosine goes away, and you're left with 1 over sine. Oops, which is cosecant. Huh. I'll be Dr. Doc.
Is 32 the same?
I think it's very much the same.
Can we do it?
Absolutely.
Wait, if we didn't use complex fractions for 32, like, end up the same answer, like...
No, you can do it. I think going to complex fractions is for 32. I'm trying to think 32 is a complex one.
I thought 34 was complex.
No, 32 you didn't need to use complex. It was 28 you had to use complex.
Yeah.
34.
I'm going to do 14 first. Yeah, Jenna.
I was going to ask your number 2. You know that.
Hold on a second here.
Oh, wait. I might be giving, you can still do it.
So I have 1 plus tangent quantity squared. Please, I'm going to FOIL it out. So I have 1 plus 2 tangent x, or tangent, and then it's plus tangent squared. What's 1 plus tangent squared? There you go.
Wait, how?
FOIL.
Oh, no, but...
You killed the puppy, didn't you?
No, I did. I did that right. I did the foiling right. What the secant squared thing come from?
Jay, let me ask you this. What's 1 plus 3 plus 2?
1 plus 2 plus 2
1 plus 3 plus 2?
Yes.
She can't do math in her head.
6.
What's 2 plus 3 plus 1?
6.
What's 2 plus 1 plus 3? Did the order matter in which I added all those together? So does the order matter in which I rearrange these things with addition? So what's 1 plus tangent squared?
Oh, okay.
I think it was, someone said 34. I'm going to do 34 and I'll come back to that, okay?
Oh, I'm probably so first.
All right. If you look at this one, there's a couple of ways to go about it. I think the easiest one is to use a Pythagorean identity. Notice how the fraction has cosine squared, a sine squared, and then a cosine. But you want to verify that it is 3 times a cosine. So what I want to do is rewrite sine squared in terms of cosine squared. So sine squared is what? 1 minus cosine squared. So I'm going to rewrite the top as 2 cosine squared minus the quantity 1 minus cosine squared plus 1, and it's still all over the cosine. Okay? What most people screw up at this point is they forget to distribute the negative to both terms. Distribute your negative to both parts. You get 2 cosine squared minus 1 plus a cosine squared plus a 1 all over cosine. What's 2 plus 1? Very good. What's negative 1 plus 1?
0.
So you wind up with 3 cosine squared and a cosine in the denominator.
Now you can square it. Make the square.
What happens?
2 falls off.
And that's all it is. This is an idea of how to use the Pythagorean identity to your advantage.
Wait, you have just done what's called a negative sine squared plus 1, which is 6 times 1.
I try to stay away from the negative angles, the setup of that, but it works. Okay. Yeah. Ah, same thing as what we were looking at earlier. What do both those terms have in common?
Oh, okay, now I get it. Oh,
What do both those guys have in common? Factor it out.
okay.
Okay? You factor out the tangent squared, you have 1 minus sine squared. What's 1 minus sine squared? And what's the tangent squared?
Oh, that makes sense. That makes sense.
And I get it, but
There's a couple of ways to go about it. I mean, you could have gone the same route by getting common denominator because you had cosines squared for denominators. Then you wind up with 1 minus sine squared all over cosine squared,
28,
which is wait. Here's something along those lines. Sorry. What's that?
28.
Oh, it's another
28 is the other big complex one you have to do. 28, you rewrite it out as a complex fraction because if you notice, you have no squared terms, and each of the numerator and the denominator both have addition in there. Write them in terms of sines and cosines, and try to fight to get your common denominator. That's really the only way of going about doing this problem. So you have 1 over cosine plus sine over cosine all over cosine over 1 plus cosine over sine. And from there, it mirrors out to be basically the same problem you just did. Do you want me to finish it?
Yes. Because I had trouble catching on to
Top one. What's the common denominator?
cosine. So it's 1 plus sin over cosine.
It's not a 9-inch nail song. It's 1 plus sine. Common denominator at the bottom will be sine. Fraction on the left needs a fraction on the right has one. So it's cosine, sine, plus the cosine. What do both of those guys have in common? Cosine, so we factor it out. Now, I'm just going to go ahead and rewrite it as 1 plus sine over cosine times the reciprocal of what we just did. Everybody okay with me doing that? We understand why I'm doing that? Okay, make sure.
Oh,
Is sine plus 1 the same as 1 plus sine? Jenna?
Yes.
Good. So they simplify out. And you wind up with sine over cosine squared. 1 over cosine squared is secant squared in the numerator. Yes.
I also had a question about that one.
Oh, 18. I tried that so many different ways, and all of a sudden I went, flip it right away.
Sine squared over cosine.
Hey, I actually was never.
I believe that's what it is, right? Secant over cosecant squared?
Yes.
Okay. What I mean by flipping it right away, secant is 1 over sine. Do you agree? I'm sorry, 1 over cosine, sorry. And then 1 over cosecant squared is sine squared. So I'm going to flip it right away, and I get sine squared over cosine squared. Or excuse me, just over cosine. This problem asked me to go into something that had a subtraction symbol at the end, right?
Yeah.
How do I turn to sine squared and have something subtraction? Perfect.
Oh,
Pythagorean triple, or not triple, Pythagorean identity. So it's 1 minus cosine squared. Are you freaking kidding me? Is correct, because now all you have to do is split apart. Split the fraction, because you've got a single value in the denominator and a double in the top. Write it as 2 fractions and you're done. 1 over cosine. You got it?
Yeah.
Oh, we're now. Try and airplane? They've done it a lot.
It's 1 minus cosine squared over cosine.
Yeah. And I split it apart. Remember, when you have a single value in the denominator and 2 in the top, it's easy to, you're rewriting it as common denominator, but just as 2 separate fractions. Because now you can simplify them individually. You got secant minus cosine. You're done. These are not easy. These get to be a bit of a pain.
How does 1 minus cosine squared become secant?
It doesn't. 1 over cosine is secant.
Oh.
That's how it becomes it. Okay? Now, what I want to do is I want to show you guys how we use Pythagorean identity built into, or any of these other identity stuff, built into solving the equations. So I've got a handful of examples to mix in with this. And then tonight I've got 4 of the equation problems and I think like 8 more of the verifies. Tomorrow, what I have is I made up a quick little like review sheet-ish, if you will, that we'll go through together as a class, as much of them as we can in class, like the bits and pieces of it, as well as give you back your quizzes so we can go over those as well. Believe me, you guys did much better second time around because you knew how to do math.
I noticed. 40% difference.
Mine was 50% difference.
Mine was around 30.
Funny.
Okay. More often than not, you did better. So let me show you an example. This is kind of the same section-ish. Remember, we're kind of bleeding all these things together here. And I want to show you how we can utilize.
It's still part of 14.
Yeah, this is all the same. This is all tricky. There's most section stuff is kind of like I've been doing all along. We're kind of picking and choosing here, okay? Eventually. It's okay. I'm not worried.
You should be.
I just said that. It's kind of a mixture of everything we've been doing. So it's 14. We'll call it trickish.
Are we allowed to lose the
We're getting tricky with it. It does.
Are you going to be recording tomorrow? Because I'm going to be here.
Yes.
Someone look it up on
Sir.
there. Are we allowed to like drop the X's halfway through the problem? This problem, do we have to keep them there?
Oh.
This is. Oh, I almost let that. Sorry about that. Now, what's going to happen here is we're going to solve for x, which means we're going to have x's in here. And we're going to solve for it on the interval of 0 between x and between 2 pi. So what we're going to do is we're going to solve for a value of a radian measure of an angle that makes this equation work. Or radian measures, there could be more than one angle. Now, what I want you guys to see here is that we have two different trigonometric identities, two different trigonometric functions in one problem. It's you don't want to try to solve for two parts at the same time. So what we're going to do is we're going to use properties of the trig identities, the Pythagoreans usually, to help make it in terms of one of them. So here's what we do. In order to have the Pythagorean identity work, there's always something squared. Do you agree? Mm-hmm. So if I have an equation and I want to do something to both sides to keep them balanced, if I square both sides, is this still a true statement?
Yes.
All right, let's do that. Square both sides.
No, we can't.
So now, on the left side of the equation, we have 1 minus cosine quantity squared. Means I have jump times jump. I have to FOIL it out. Okay with that? You killed a puppy that fast? Oh my God. Jeez. So you have 1 minus 2 times the cosine x plus cosine squared of x. Straight FOIL. Okay? On the other side, it's a monomial. There's no addition or subtraction sign. When it's a monomial being squared, what do you do with the square term then? That's when you distribute. So the square root of 3 squared is?
9. Oh wait, it's 3.
3. So now you have 1 minus 2 cosine x plus cosine squared x equals 3 sine squared x. Okay?
No.
It doesn't look any better right now, does it?
No.
Now, let's think of it this way. If you look at it, see how we've got more cosines than sines?
Yep.
Can we what's up?
Oh, wait, never mind.
Okay. Can I rewrite sine squared in terms of cosine squared?
Nope.
You sure?
Yeah. You can make a cosine minus 1.
Careful, is it cosine squared minus 1 or is it 1 minus cosine squared?
1
minus cosine.
So, first thing I'm going to do here, because I get crazy with these things, I'm going to rewrite this as descending order on the left, and then rewrite sine squared in terms of cosine squared. Okay? So I get cosine squared x minus 2 cosine what I did there is I rewrote that sine squared by using the Pythagorean identity to a cosine squared. Now at least I have all cosines. Okay? Distribute your 3.
Is it possible, just for the sake of not getting confused, like substitute cosine with like a letter like U?
Absolutely. Absolutely. If you at this point now, what Clay is saying is to use that U substitution. I usually do it when I get to the factoring part, but by all means, if you want to do it now, bless you, go for it.
Okay.
Okay? Which leads me to, we need to set aside equal to 0 to solve for x. Subtract the 3 and add the 3 cosine squared x. Okay? What's 3 plus 1?
4.
What's 1 minus 3? Now, Clay, this is usually where I go to the U substitution, just because I've moved everything around. And if you want to do it beforehand, go for it. There's nothing wrong with it.
Okay.
You guys remember what I mean by that U substitution?
Yeah.
Yeah, let cosine equal U.
I am nothing like those.
You're not. You're more like a sine.
I am.
And I saw that sign. remind me to read you guys an email that I got from a parent a couple years ago. You guys all got the email that I sent out that here's the attachment sheet. Did any of your parents annoy you with that?
Wait, emails?
You don't, but it's easier for people to visualize the
Our
fact.
parents.
Yesterday I sent out, or 2 days ago I sent out an email about the test coming up, and I sent out one of the verify sheets, for extra practice. It's the one you already got. And a lot of times when I send out emails to parents, I kind of funny and say, you know where I'm going with this. Say, hey, hide these things around the house and harass your children and say you can't eat dinner until you verify this and things like that. So I know like Izzy, poor Izzy. Izzy had copies of math problems like in cereal boxes, the fridge, the shower. It was all over the place. Austin had no idea until he opened up his golf bag. There was homework problems. Like, how the hell did my mom know what my homework was? So it's just funny things. But a few years ago, I had a student, same section. I sent out one of the trig identity sheets, say, hey, practice with these things. If you want to be funny, quiz them on this stuff, and I'll send you the answer guide. A parent emailed me back their receipt. So at this point here, when you've got a trinomial set equal to 0, what's the first rule of factoring? If I take out the GCF, what can I do with that 2 then? Does it go away? Why does it go away? Well, when you divide by 0 by 2, what do you get? 0. So it has no bearing upon the problem. Okay? So now you have to factor by grouping. So 2 times -1 is what?
2.
What times what's -2 that gets you -1 when you add it? Yeah, so you have 2u
I
squared.
took the GCF, oh crap.
You okay?
Yeah, and that's why I was really confused.
You factored by grouping and take out GCFs again. I'm factoring the trinomial. You ever heard of it called split middle term? No, it's just another way of doing it. We did it earlier this year a lot. So now I have my 2 terms that I can set equal to 0. What did I do wrong? You okay?
No, I just thought. Never mind.
Okay. So now, is it okay if I go back and rewrite with cosine again?
Yeah.
All right, so I have 2 times the cosine of x minus 1 equals 0. And cosine of x minus 1 is 0. So that means I'm looking for the angles that, what's up?
Wait, isn't the cosine of 2 plus x plus 1?
Thank you. Thanks, Val. I did that earlier today, too. I was checking to see if someone was paying attention. So now, remember, when you're trying to solve for your angles, you're asking, find the value of x, find the val, u.
You said that like 30 times.
I know, but this time.
What angle has a cosine value of -1/2?
Oh my God.
Subtract 1 divided by 2.
It's -60.
So when you're thinking about it, what angle has a cosine value? Cosine's negative here. Here's your -1. Here's your 2. What angle is that? 60. But what's your theta value coming across?
Pi over 2.
That's 2 pi over 3.
2 pi over 3.
Math.
So your answer is 2 pi over 3. Where else is cosine negative? Right below it. So what's that value?
Would you have to do like the plus 2 and 2 pi?
No, I don't have to do anything with the 2 pi n because I've set the parameter within the boundary. When I do these solve equations, it's going to have the factoring. I'll make sure you just put the parameter in. What's up? I'm sorry. Oh, Emma, you had it. Sorry.
Yeah, not earlier, I had to push my phone, but it's this kind of thing, like when you push things out with a calculator, should be green, or for you to run in, like.
Well, you won't get a calculator. Okay. And now, what angle has a value of cosine of 1.
The horizontal quadrant and the quadrant.
At 0.
Quadrant. What's it called?
0.
What's the what are those quads called? They're called
Quadrantals.
Quadrantal.
So in this case, in this case, there happens to be 3 solutions that solve the equation. And that's how it works.
Yeah, are we gonna have it streaming
It's
this?
4 pi over 3 like
Yeah, because your reference angle is pi over 3. We're going to drop it down. Okay. Let's try another one.
I thought I did my notes on backwards pages.
What's up?
one of these questions is just gonna be like 1 page.
Some of them are shorter than others. Yes, sir.
Why didn't we go back and find the sign in the last problem? Because we had cosine and we had sine, but we got rid of the sign.
Because we wrote it in terms of cosine.
But why don't we go back and?
We don't have to, because we rewrote. If you substitute back in, you'll get this, it works. That's all it is.
If you choose cosine or sine, it doesn't matter. It's like, oh, okay.
In that case, it forces you to do the cosine, because you get cosine squared, because you've got that term already there. So it's kind of one of those things. Now, in this one, I have cosine squared minus sine squared equaling 0. You want to say it's wrong, because you want to say it's 1, but that's when it's adding. When you're subtracting the 2, it's different. So, does it matter which one you choose to replace? No. So far today, we've been replacing it cosine squared with sine squared. You want to just continue that?
Sure thing.
All right.
But I already replaced sine squared.
All right, we'll do sine squared.
Yay!
All right. So we have cosine squared of x minus the quantity 1 minus cosine squared. Is that what you had?
Yes.
Did you distribute your negative correctly?
Yes, I did.
If you distribute your negative correctly, you wind up with how many cosine squareds?
2 cosine squared.
And a partridge in a pear tree.
There was an episode of
Got
Fairly
cold.
Odd Parents where that was
Now-
true, and let me tell you, it was a disaster.
Now in this one here, this is very similar to ones we've done.
So is it,
Add 1 divided by 2.
so the negative cosine, the inverse cosine of 1/2?
Yeah. Now, you take your square root, you're asking yourself what angle has a cosine value of plus or minus 1 over root 2. Because you take the square root, you don't have to rationalize.
Oh, that's so
bad.
It's a 45-degree angle, isn't it?
Yeah.
So it's at pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Now, in all honesty, did we really even need to do all that math? Nope. Shouldn't have. Why? You don't know?
You could have added sine squared and divided by cosine squared, and you would have just math.
It's just math?
Yeah.
We can just skip the student.
And you got tangent squared.
Hold on a second here.
tangent.
Not learn.
Technically, we don't change any of this ever.
Remember, when you're talking about your reference angle as far as the ordered pairs for sine and cosine at 45 degrees, remember they were both root 2 over 2? So if I took, and what comes first, sine or cosine in an ordered pair? What's root 2 over 2 squared? I don't care, it's some number. If I subtract it by root 2 over 2 quantity squared, what am I going to get? 0. Because the ordered pairs are the same. So,
Could I just like drop Mr. Flores up there?
I just saw that in search and I agreed with it. On the board, right there. Highly agree with it.
2 secant squared of x minus 2 times tangent of x equals 0.
You said 2 secant squared.
Oh, I'm sorry, secant squared of x, I'm sorry. Secant squared of x minus 2 times the tangent of x is 0. Now, in this one, which one do you think it's forcing you to replace? Why is that?
Because that's a fraction.
Because it's Pythagorean, it's that too. So secant squared is equal to what?
1 minus
One
cotangent
plus
squared.
tan squared.
So isn't this just tangent squared of x minus 2 tangent of x plus 1? I just moved them around.
Now we can.
Do I need to use u substitution, or is it okay that I can just say what times what's 1 I add together to get -2?
So it would be -1.
Right. I don't have to use u substitution here if I don't want to, since it's not that messy.
So it's maybe 1.
Yeah, so you just wind up with tangent of x minus 1, tangent of x minus 1. So, what angle has an inverse tangent value of 1? And where else? Radians. Somewhere in the circle. That narrows it down infinitely.
In the pi over.
Oh, the
Well, it's in
Pi over 4, not pi over 4.
Whoa, 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 whoa.
science.
Oh, yeah, it's on the.
Pi over 4, 5 pi over 4.
British flag.
It's almost a British flag, not quite.
It's close.
It's actually, what would that be, 1, 2, 3, that'd be 8, so it's 3/4.
It's close.
So it's,
3/4 is a passing grade in my book.
okay, so it's pi over 4 and 5 pi over 4.
75%. That's pretty good passing grade.
Okay.
In this class, at least.
Yeah.
You tell someone you got a 75 on your calculus, oh, that's so good. Yeah, great. It's a miss. A math miss. Oh, no thank you.
Solve it. Yeah. Yeah.
Oh, no, we don't have to verify.
I want you to solve for x within 1 revolution. You might be pleasantly surprised. It's not as awful as what you want to say it is.
Wait, the middle term is what you add, right?
Yeah. When you're factoring, yeah.
All math.
Are we okay with that part there?
Were you?
I'm hoping you guys change secant squared to a tangent squared because you have so many more tangents going on. So we wind up with 2 tangent squared x minus 1 plus the tangent squared of x plus 3. I'm going to bring the other stuff over. Minus 1 plus the 2 tangent of x. All I did was just move everything over. Clay, this part you probably wrote in terms of u.
Actually, I wrote terms of you after I think.
Wait,
It's fine.
Would that be minus tan squared?
There's x minus 1 minus 10. Yes, thank you.
Oh, never mind.
Okay. Now I'm going to combine my like terms. 2 tangent squared minus tangent squared is how much tangent squared?
Tangent
A lot of
squared.
tangents.
Not enough tangents.
I have plus 2 tangent here. -1 plus 3 minus 1 is?
A number.
Oh, what did I do?
What times what is 1? You add together to get 2.
One.
Oh, crap.
It's one of those.
One.
So what angle has a tangent value? -1,
Yeah. 3 pi over 4 and 11 pi over 4.
3 pi over 4, and 7 pi over 4. Perfect. It's not as bad as it looks. It's just that little subtle trick. And then remember to distribute out.
It is as bad as it looks. Actually, this is application.
What I want you guys to work on tonight, I want you guys to do on the back side of what you just did. These are some more of the verifies.
Oh, I didn't rip it out.
I want you to do the verify, the first 8 on the back side here of verify, as well as in section 14.4, it's page 859, is it 20, I forgot.
This one's there, right?
27, 29, and 30, and then 37.
Yeah, I'm just gonna remove it now.
Okay? The 4 out of the book are solving equations that have trigonometric identities built into them. So, or you might have to square both sides to create one. So the examples that we've done in class really do mirror what you guys have for tonight. Yes, ma'am? The top 8. 1 through 8. That would be the
I
top
wrote on the board for you. I always do.
8. Okay? Yeah, I just have some review problem stuff.
Probably gonna come over and flex on Friday.
I got sick in there. I got sick in there for sour. Yeah, it's not
It's not physical.
your brain is
Yes, ma'am.
wired.
Once I do that, I gotta stop this course going too.